morning one and all. Today I am discussing about calibration of triangular notch, is popularly called as V notch, to find coefficient of discharge CD under Module 2 Lecture Class 1 of Fluid Mechanics and Hydraulic Machinery Laboratory with a subject code 18CVL48 for 4th semester students. So the content of today's laboratory discussion is to determine the coefficient of discharge through triangular notch, or also called as V notch. The aim of the today's experiment is, as I said earlier, to determine the coefficient of discharge V notch. The apparatus are V notch, collecting tank, constant headwater supply, measuring scale, stopwatch. You can see here the isometric view of the V notch. So here the angle made by these two cutting edges through which ejection of water takes place from the flow play a vital role, and this is about your theta, the angle between two cutting edges. And this is the sketch, the actual photo which we have taken from Government Sri Krishna Rajendra Silver Jubilee Technological Institute, Fluid Mechanics and Hydraulic Machinery Laboratory. You can see here, this is the flow tank and this is your measuring tank. This brass one is your V notch. Suppose I wanted to make a rectangular notch survey to determine CD. There is a screw arrangement is there, 3 screws here, 3 screws here, 1 screw here. If you detach it, you can fix the rectangular notch. Okay, so coming to the that is the theoretical part. There is a flow tank. This is your flow tank, and in the tank there are buffer walls will be there. When the inlet water flows here, the water will start collecting up to here. Then through this buffer wall, the water starts collects here. Again this buffer wall, the water starts collects here, and here we have an opening. So because of this opening, in excess of water of this head, which will flows here. Okay. So that flow of water is collected in this particular tank, and this is called as a measuring tank, because here we are measuring the collected water quantity. Therefore it has derived its name measuring tank. Okay. And so here there is a regulating valve will be there. Some instrument will have circular regulating valves, some will have a that is a straight regulating valve will be there, through which flow takes place. If I take cross section here and if I view it from this direction, it looks in this fashion. So from this bottom, that is here, from here if I measure here, that is H1. From here, if the flow takes place up to here, means it is H2. So from here it is H1 and here it is H2. Next, coming to the theoretical approach before going to the experimental part of V notch, means a V notch is commonly used for measurement of a small discharge. So small discharge in an open channel. This is open channel. There are two types of channel. One is closed channel, another one is open channel. Okay, so pipes conduits are closed channels, canals, nalas are open channel. To stimulate that condition here, we are using this tank of open channel. So a V notch is a shape of a triangle with an apex at the down, base at the top. Therefore, it is also called as a triangular notch. A V notch usually consisted of a metal plate. As I said earlier, all these things, I am just recalling that one, metal plate with a sharp crust having a bevel edge at the bottom, so that the liquid spills off the V notch only in a line of contact. Because we are using a gauges, the gauge pointer end touching point we are recording it, that is the height. The stream of liquid is called nappy, that is the flow of liquid from here to here. When the flow is low, here; when the flow is high, here, that is called as a nappy. A nappy should be fully ventilated so that the pressure below is atmospheric pressure. Coming to the calculation, what we have to calculate here? We have to calculate coefficient of discharge. Coefficient of discharge is called as CD. How to calculate coefficient of discharge? Coefficient of discharge CD is equal to Q actual divided by Q theoretical. As I said earlier, any measurement we are done from the tank where actual water is collected, that is this tank where actual water is collected, is called as actual discharge. Anything we are doing by taking some of the data like angle between the two inclined surfaces and by using a theoretical approach is called theoretical discharge. So what should be the actual discharge and what is the what should be the theoretical discharge and what is the actual discharge that we have to calculate. If your instrument is 100% intact in nature, CD should be equal to 1. When CD should be is equal to 1 means Q theoretical is equal to Q actual. So the discharge actual is given by formula AH by T. As I said earlier, A is nothing but what, students? A is nothing but cross-sectional area of measuring tank, which is also called as collecting tank. The water which collects in a tank is called as a collecting tank, or the tank in which we are measuring the collected water is also called measuring tank. Or bottom may be different. H is nothing but your rise in the water level in the collecting tank. So there is a piezometer will be there. With the help of that we are measuring the height. T is the time for H mm rise in the tank in seconds. So now coming to the theoretical discharge, Q theoretical is equal to 8 by 15 root of 2g tan theta by 2 whole to the power 5 by 2 in meter cube per second, where g is called as an acceleration due to gravity, which is given by 9.81 meter per second square. Theta is nothing but half angle we are considering because the entire thing here. So 50% flow we are that is flowing through this sloping edge, 50% flow through this sloping edge. Therefore, theta by 2. Theta is angle between these two lines. So now theta is the V notch angle. Head over the crust from here H1, here H2. This is crust. Over the crust means H2 minus H1. So is the head over the crust. Substitute it, you will get Q coefficient of discharge CD. Coming to the procedure, measure the apex angle. This is your apex angle of V notch. Okay, so how to measure it? But before fixing this one in position, you can take a paper, draw the sketch, and using conventional protractor you can measure it. Okay. Next is open the supply valve as I shown in the beginning, supply valve, record the hook gauge reading. When you open the supply valve, water start flows. When it first nappy moves, hook gauge, you bring it here and record that reading. When water just starts sprinkling over the crust, regulate the supply valve till the flow becomes steady and the head over the crust and the crust become constant. Take the hook gauge reading. That means when the second reading you have to take it. Take the readings of the water level in the measuring tank and stopwatch. Note down the rise in the water level in the tank. Below this you will have a tank. So what is the rise in the water level in the tank? How much time it takes? Or other way is marks 10 centimeter here or 5 centimeter here in the piezometer. Initial reading knows, final reading knows. To rise that level, how much time it has taken, you record it. The increase in the discharge by regulating. So first you open the 25% valve, second you open 50% valve, more water will flow in a short period of time. Next you open 75% valve, further increases the flow with collection of water in the tank, time get reduces. When fully open the valve, quickly water start collecting in the measuring tank. So for rise of 10 centimeter, time record will be less. So now let us have some typical calculation for better understanding purpose, because without calculation, whatever we explain, it is like a theory. So therefore, I made an attempt to do the calculation in this class, so that you will have a better grip over the subject. Apex angle V notch is measured angle 45 degree. The dimension of the measuring tank. So L and B is known, that is area is 0.174 meter square. 4 trial with the varying the discharge valve opening we are done, and it has recorded in a table composed of initial height h in meter, final height h2 in meter, initial height h1 in meter, h is equal to h2 minus h1 in meter, h 4 to the power 5 by 2. Just for better simplifying our calculation, the equation whatever h by 5 by 2 is there, that we are made it as one column. Q theoretical is meter cube per second. Q theoretical is given by formula. So this one 8 by 15 root of 2g into tan theta by 2. So into h whole to the power 5 by 2. And rise of water in measuring tank, 10 mm rise. What is the time taken? And Q actual AH by T meter cube per second. Q actual by Q theoretical, if you do it, you will get CD value. So now, first trial. Okay. In the first trial, the time taken is more compared to the last trial, because first trial the valve opening is only 25%. Therefore, more time has taken to rise the tank of water to an height of 10. So that is mm, or that is whatever height you require. We taken this as an example. Second trial, valve opened is 50%. So the time required to fill the tank of height 10 mm gets reduced to almost 50%, 17.6. Third trial, the valve opened was 75%. So more water is allowed in this tank, so that more quickly tank is filling in the measuring tank. Therefore, time required to fill the 10 mm is further 6.1. Fourth trial, full valve was opened. Therefore, quickly the tank has filled to a height of 10 mm, which time taken is 5.6. Hook gauge reading H1, hook gauge reading H2, difference of H2 minus H1, and this value, that is initial hook gauge, because at nappy point, at the initial nappy point, H1 hook gauge reading will be same when flow increases for 25%, 50%, 75%, 100%. As the flow rate increases, you can see the height of path traced by a water flow projectile is also increases. That height you have to measure it. So that is For first trial it is H2 is 0.096, second trial 0.107, third trial 0.113, fourth trial 0.118. That means height constantly, the height of water increasing quickly here because the flow rate is more. So therefore, so you substitute in this one, you will get Q theoretical and AH by T, this one this, and tank area will get Q actual, CD Q theoretical, Q actual by Q theoretical. If you do it, you will get coefficient of discharge. Take average of 4 readings, you will get CD value 0.73. So we made one more way of calculating CD by using the graph. You can see here we prepared a graph of Q theoretical on x-axis by Q actual on y-axis. I taken 2 units is equal to, so 10 to the power of minus 4 meter cube per second on x and y axis. 4 points you will get equal area method, you plot a line, you will get a flow line, and slope of this line will give coefficient of discharge. That means a reference length 1 centimeter or 1.5 centimeter I taken here. I join this one. AB by BC I taken 2.4 minus 1.5 divided by corresponding this one 3.55 minus 2.35. If you do it 0.9 by 1.2, you will get 0.75. If you see here, theoretically 0.73, graphically it is 0.75. I plotted this actual scale, but not in a graph sheet. In a ordinary sheet I plotted this one. Okay, so to have a better understanding purpose, I shown to you for this instrument. So the theoretical and graphical procedure is giving almost same results, and you have to record in results column coefficient of discharge in V naught is analytical value 0.73, graphical value 0.75. Coming to the multiple choice question. Question number 1, the actual discharge for calculation of CD using V naught is given by Q actual is equal to AH by T in meter cube per second. Option A is true, option B is false. So option A it is true, therefore it is A. Actual discharge is calculated, calculation of CD using V naught is given by AT by H. So A is in meter square, H is in meter, meter square meter, it should be meter cube per second. If you take this one meter per second, it will give velocity, but meter second you will meter second you will get, it is not meter cube per second. Therefore the option is B. Theoretical discharge for calculation of CD is given by, so 5 by 13 2g tan over to the power theta by 2 over to the power of 5 by 2. This is wrong, that is B. Theoretical discharge for calculation of CD using a V naught is given by 7 by 15 root 2g tan theta by 2 h over to the power of 1 by 2. This is also wrong, B. Theoretical discharge for calculation of CD using a V naught is 8 by 15 root 2g tan theta divided by 42 h over to 5 by 2. This is also wrong. Next, 6th one, theoretical discharge for calculation of CD using a V naught is given by Q. Theoretical is 8 by 15 Q tan over theta by 2 h over to the power of 9 by 2. This is also wrong, false. B. Theoretical discharge for calculation of CD using V naught is given by 8 by 15 root 2g tan theta by 2 h over to the 1 by 2 meter cube per second. This is also false. B. Theoretical discharge for calculation of CD using a V naught is given by 8 by 15 root 2g tan theta by 2 h over to the 5 by 2. So this is a correct one, this is A. Then coefficient of discharge for calculation of CD using V naught is given by Q actual by Q theoretical. This is correct, therefore it is true. If actual discharge is equal to theoretical discharge, then CD value will be 1. If actual discharge is more than theoretical discharge, then CD value is greater than 1. If actual discharge is less than theoretical discharge, CD value is less than 1. In the present example, you can see actual discharge is less than the theoretical discharge by 0.25%, 25%. Therefore, we got CD value as 0.75 in and around 0.75. Next, 10th question, coefficient of discharge for calculation of CD using V naught is given by Q theoretical by Q actual. This is wrong. Okay, so because if I say actual is more, okay, if I say actual is more, so theoretical will never be equal to x times the actual, therefore the statement is false. So I take this is a reference books, and the equipment which we are shown is the courtesy of Government SKJTI College, Department of Technical Education, KR Circle, Bangalore 1. We take this opportunity to thank Department of Collegiate and Technical Education, all higher officers, for giving me an opportunity to deliver this lecture, and also I take this opportunity to thank students community across government engineering colleges in Karnataka for listening my lecture. I request all the students go through the LMS portal and practice the MCQ questions and study the material given. Typical example for the benefit of students only we did it. Kindly go through the typical calculation, because calculation is a very important in fluid mechanics lab. Procedure looks like simple, but calculation conversions are very important. Millimeter to meter conversion, meter to millimeter conversion. So a substitution will give some final unit. If you are not aware of it, then it becomes problem. Keeping all these things in mind, so I did typical calculation. Please go through it. If you have any doubt, you can feel free to ask in my lecture related to my lecture classes. Thank you.